here is the write-up. Okay, and so the write-up it's not that long. It's like 3 or 4 pages. Uh, so what I've done essentially is given you some code to help you get started. It's not like you're writing things from scratch. Essentially, I've broken it into 2 stages, and I'll talk about it a little bit over here. So the code which I provided to you, if you open that, I'm going to open that in a bit. Okay. Okay, let me run this. So first thing you do, just run this code. And then you see that there's a ball and that goes and it actually penetrates the pedal. And that's because I have not programmed the pedal to detect the balls. That's something which you will do. The code which I've provided actually is basically has this main chunk. So if you remember when we did simulations, we had a main block and then there was functions which were called. So the main block is shown here. It essentially calls 3 things iteratively: move ball, move pedal, and refresh plot. Okay, it does so till the game is over. So the game is over, then it stops, kills the program. Now you are going to program these 2 functions, move ball and move pedal. As the name suggests, move ball is about the physics of the ball, keeping track of that, and move pedal is keeping the track of the physics of the pedal. Okay. Uh, so let me scroll to that in this code. Okay. So if you go to move ball, okay, this is again keeping track of the ball position using Euler's integration. This is something which I just talked about, right? It basically is the ball x position is the previous position plus speed times dt. So you are going to essentially write code here, which will tell the ball that once it hits the left or right side or top or the pedal, it should basically rebound. Okay, and how do you do that? Well, I actually given you what it needs to do. It's basically if it hits the left or the right wall, then the speed, the y is upwards, should remain unchanged. And then the x speed basically is this formula, which is based on the coefficient of restitution. Okay, so this is basically your dynamics course. When you took dynamics, you basically studied this formula, how to use the coefficient of restitution, essentially coding that restitution into this game. Similarly, when the ball hits the top wall or the pedal, then the x speed is unchanged, but the y speed, which is the vertical speed, is going to be affected by the factor e, which is the coefficient of restitution. And since it's a game, you can put whatever you want for the coefficient of restitution. So I've given some suggestions. So that part of the code will sit here and make the ball being detected by the walls and rebounding. The second part, which is the move pedal, this is where you will edit the pedal part. So if you run this code, I'm going to run this again. If I keep moving the pedal, you see that the pedal actually disappeared from the screen. And that's because I've not put a stop to till what part of the screen the pedal should move. So in this case, it just keeps moving to the left. Eventually it disappears from the screen. So this code here will ensure that it doesn't move past the left and right side of the screen. So once you do that, okay, I have the solution. I've already did that. Your pedal will look like this. I cannot go to the left, however hard I try. It'll actually rebound from the walls. It will rebound from the pedal. It'll go to the top wall, rebound from the top wall. Okay, and then when it actually goes down, it actually stops the game. So you can see it stops the game here. So the first part in this project will be about making these basic changes to the code. So once you are got that working, then so these are a few things you might need to get it to work. So I've given you positions for the y, the max min of the wall, also giving you the position of the pedal, and you'll be using in a if-else loop in that code so that walls are detected, and then you'll use the rebound condition which I just described. So once you get this going, then the second part is, and this is the fun part, which is programming an advanced part of the game, which is you need to create some visual elements, and you can be very creative here. You could add, I don't know, balloons or bubbles and whatever you want, and if the ball hits that, you get extra points, something like that. So think of how you can make this game more interesting, more fun to play. You could also add scoring criteria. In fact, here I actually have displayed something in the, so you can see this level 0. It's actually, okay, there it is, level 0. This actually is a part of the title, and you can actually put the score there. If you want to put score somewhere else, there is a command called text which you can use to put code there, so you could keep track of the scores. So that's another suggestion, but feel free to add your, come up with your own ideas. I think I've put a constraint: you need to add at least one visual element, so that will test you on putting uh, whatever you want. It could be a balloon, or a red dot or yellow dot, or whatever you want. uh, you need to put that. That is one requirement I have in this project, but you need to also add two more things, and these two things, extra things, are up to you. Okay, the grading is here. What we'll do is, instead of you submitting a report, which I think is just too much time consuming, we'll actually have like a one-on-one or one-on-two, if you're in a group of two, meeting, where you will essentially show me if you successfully completed stage 1, which is basically detecting the walls and the pedal, and then your second part, which is putting some advanced features, will also be demonstrated during the same meeting. So I'll tell you how we'll go about doing this meeting, but this will take basically 5 to 10 minutes of the time to do this. Okay, and so then finally you need to email me the submission. So what we'll